Hi everyone. Um, Hopefully you have made it back from the break. Right. So hopefully you had a chance to do the exercise. So what I was asking from you was to add a few rules into our Makefile and to change the order so that by default it would create our results.txt with a summary of the analysis of the different text files. So let us first try to solve it by adding the first rule for the new for the additional text file that was last.dat that is located as the others in our books directory, and this will run the same command. Words and we'll run this Python command. So that will be the first new rule into our Makefile to process that new file. Next thing that the exercise is asking us to do is to update our DATS phony target, and we can do that by doing this, adding a dependency for which we already have a rule. And now we want a new rule to create a summary results.txt. That one will be convenient to have it at the top because we know that the first target that Makefile finds will be the default one. So having the end file, the summary file as a default target will be useful. So I add it at the top. Txt, and then the dependencies. They will depend on well, what we need to we need the DAT files created first. So we can either add it in this way using the funny target, or we could specify every single DAT file like isol.dat, avis.dat, last.dat. So it's equivalent in this case because we already have a target called that. So now we need what rule should be executed. What action should be executed for this rule? In this case, we will run our Python test cpf.py and then give it what are the files that we want to process. So .dat and last.dat, and we want to save this into our results.txt. And yeah, finally, if we want to rerun or make file or this script from scratch, we might want to clean before doing that and recreate. For that, we probably it's good to remove the results.txt file because we might want to recreate it if we change our text files. So that should work. I don't know if anybody had any doubt with this exercise. If you do, please put it in the chat. We can try to answer any questions you might have. I should probably try it first. So let me do a make clean. But yeah, it will now this new this new command that I just added, and hopefully, if I do a make, if you just run make, it should hopefully, yeah, that's so what make is doing now is, let me open the make file, is trying to execute the first target that it encounters. So it will find results.txt, and it will find that it depends on this target, that's, and the that's also depends on other files. In this case, idle.dat, abyss.dat, and last.dat, and those, they have different rules. And then it checks if those targets need to be, and they do, because we just remove them after the make clean. So it runs first this series of actions, and then once those are run and that files are created, we can finally run the action for results.txt, the default target. So hopefully that makes sense. You can see here that yes, the dat files were created first, and then result.txt was created at the end. If we were to hopefully that kind of makes sense. Let us move on to the next section. That is about automatic variables. So now our makefile looks more or less like this. Oh yes, I noticed that. I was using a Mac, and I saw that file being created. It might be, yes, it might be platform specific. I haven't seen it before. But I think it's not getting in the way, so let us ignore it for a moment. So I wanted to draw your attention towards another concept. So far, I think we're putting a lot of different actions in our makefile that is hopefully starting to make sense and how this could be useful. But there is something that we should try to avoid. We should try to avoid repeating ourselves, meaning if we have repeated code in our script, we should try to remove the repeated code. So basically, we don't want anything repeated. Anything that can be, we can run the same commands with only one line. That is what we should try to do, because that will minimize the chances of making mistakes. So for example, so the first thing that we could try to do is for example, taking a look at the first rule, results.txt. We could use one of the automatic variables for make. So we could, let me just place myself at the end of the line here. So the first variable that I want to show you, it's this one. So it's a dollar symbol and an @ symbol. And what that means, it is replaced by the name of the target. So every time I run this file, and every time make tries to run this target, this rule, this symbol, this dollar symbol, @ symbol, will be replaced by the name of the target, in this case results.txt. And then it can be easier, because if I need to modify the name of the target, I just need to do it in one place, in this case results.txt, and it will be automatically replaced in here as well. So I can also use another one, which is another automatic variable that gives me access to the dependencies. For that, it will be useful to actually list. It will make more sense. I think it will be the same. It will be the same outcome, but just for the sake of clarity, let me just enumerate every one of the dependencies that I have. These three dependencies. So in make, I can use this variable in here with this other symbol, caret symbol, I believe. And what that does is this symbol gets replaced by the dependencies of my rule. So this dollar sign, dollar symbol, caret symbol will be replaced by this this number of dependencies, any dependencies that I specify for this rule. So let me save this at this point, and if I do make, it will say everything is up to date because I just run everything. But let me force mimic a change in one of the files with using the touch command that we used before. Books, and I will just mimic that I make a change in every single text file in my books directory. So now if I do make, I could do make, or I can specify. It's more or less the same because it's the same. It's the default target, and you can see this the same result. So it will go ahead and process every single, try to produce every single dat file, and then at the end it will run this command. And you see here, oh, sorry about that. It replaced the symbols that we just I just mentioned by the right values, and we can explore what our result symbol say looks like. It seems to make sense. Right. Now, say that I want. So there's another exercise, and in this exercise, the only thing you're required to do is running the command touch.dat. So trying to update, mimic the update of all of that file, or all of our dat files, and rerun the make results of txt file command. And you're asking to try to predict what will be the outcome of that, and if that makes sense. So before actually running the make results.txt, what will happen? So nothing. Everything will be recreated. Only the dat files will be recreated. Only the results.txt, the summary file will be recreated. What would you expect? So feel free to do it, to think about it for a moment, and then the command if you want to confirm your hypothesis, and see if you can put in the chat if you want. So if you try to think about this for a moment, so if we haven't updated the text files, so those haven't changed. We only updated the dat files. If we take a look at our make file, the dat files, in order to answer this exercise, you will need to think what targets depend on the dat files. That's the question. So if you take a look at your rules, you can see that the dat files depend on the txt files, but those haven't been updated. The only one that depends on the dat files is the results.txt. So after a change in these files, the only one that should be recreated is the results.txt. That's what you you would expect. So if I try that result.txt, you see that yeah, only my results, that the action for my results.txt target was the one executed. And yeah, after reviewing our makefile, that sort of makes sense. That's one way to try to understand how a change in your pipeline and the different files that composes your script will affect the behavior of your workflow. Right. Let me move on. Let me open again my makefile. Right. So let me introduce you to the next automatic variable. Say that I just show you this one, the dollar symbol and caret symbol that allows you to use every single dependency that is provided to a target. That is useful. That allows you to save a lot of repetition. It could be useful to use it in the other rules as well, but say that we want to use it in here and for our first stat file. So you might be tempted to do this, and that will work because now this dependency will be only dependency that is provided to my dat isles.dat target will be replaced in here, which is correct, and this will work. However, what about if I were to change, if I were to make a change in my countwords.py, as we did at some point, by modifying the width of our bars, but it could be any other change. You could expect that change to have an impact on the dat file that it produces, right? But at the moment, this target doesn't have a dependency on a change in countwords.py, doesn't it? So let me save this. So if I do make, everything is up to date. Say I touch my countwords. I did some kind of change in that directory and in that Python script, and now that should have some impact, but make doesn't obviously say that everything is up to date because at the moment my dat files doesn't have dependency on that particular Python script, and that's not good because obviously by making a change I could be changing the outcome of those dat files. So it will make sense to add a dependency here for this script. But now, by using the symbol, dollar symbol and caret symbol, that will also include this dependency here, right? And that's not what I want. I only want this dependency. So one way to solve that is by using this other automatic variable, which is this one. So this lower than symbol, and that what it means, it's replaced by the first dependency of the current rule. So in this case, only this one. So now let me save this. Hopefully, you see now that it will run the rule for isles.dat, because now I specify that one depends on countwords.py. And because that changed, it also needs to rerun the creation of results.txt. Hopefully that makes sense. And now what the next exercise is asking you to do is to rewrite all the other rules for the remaining DAT files to use this automatic variables that I just introduced to you. So the add symbol, the caret symbol, and the lower than symbol. So I can give you a couple of minutes to do that and test if you want. Let me just close this. Yes, basically, give it a try. Give you 2 minutes, and I'll be back. So we can do it together. Why do you? Oh, wait. Count words of pi. I assume you mean in this line, in this rule? Yes. So why I repeated, you mean why I added it in here, or why I added it in the second in the action, or why is there at all in the first line? So why I added it in here is because this my dat file is created by running that script, right? So I need to run Python and then the Python script and then the 2 arguments, and that will produce the dat file. If I were to modify this script, this Python script, if I did some meaningful modification, you will expect it to change the result of what is saved in the dat file, right? So it makes sense then to say that this dat file should have a dependency. So make should take into account that the content of that file depends both in the input file, but also on the actual script that produces it. That's why, yeah, that's why we should add it as a dependency. And the same goes for the other 2 dat files. So yes, I'll give you 1 more minute to test your changes, and that's a good question. And I think I know what you're asking it. I haven't used one. I don't know if Juan or William have used one automatic variable that accomplished that objective, but there are some workarounds to try to specify different dependencies. One of which I will try to explain in a moment. Right, I probably should continue. So hopefully you have a chance to understand what the question was, what the exercise was, and try to give it a try. So what you were asked was to use the automatic variables that we just saw to try to reduce the number of repetition, the amount of repetition that we have in our current makefile. So say here you can see that I'm using idles.dat, and then again I'm reusing it in here. The same goes for avis.dat and avis.dat here at the end, and the same for the .dat. So I can replace this by this using this automatic variable. Then we'll replace the target name. I can do the same here. I can count words.py and also count words, because the same logic applies for avis and last.dat as they apply for avis last.dat. That's why I'm adding count words.py in here. And I can use this variable to refer to my first dependency, and hopefully that should work. We can test that. I can save it. So if I do make clean, it will remove all my dat files and results.txt. And if I do make again, it should hopefully produce something very similar. It should produce exactly the same as before, which seems that it does. Good. So now our makefile looks like this, slightly shorter, with less repetition. So let's move on to try to even reduce even more the amount of repetition that we have, and try to add more functionality. Okay. So yeah, I did mention why I added the count words.py, which is fine. Right. It might be sometimes a good idea to try to do a dry run of the changes that you did in your makefile. So let me show you how to do that. Say that I updated one of my Python scripts, so count words.py, for example. That will impact my targets, because my dat files have dependency on that script. But say that I don't know that. I would like to know a change in that file. What would trigger in my makefile? So I can test that by running make with this -n, for example. And this just runs like it's a dry run, and it will show me what are the actions that will be performed. So it will run this Python count words. It will try to produce these stat files and then produce the my results.txt, which makes sense. Right. So I think so far we're starting to add more dependencies and more variables that the more makefiles start. It's starting to look a bit more complicated, but hopefully it's clear. Or if if anything is not, if anything is not clear, please just please let me know. Right. So now that we can continue modifying our makefile. It makes sense, as we did with the count words.py, added as a dependency for the dat files, that we could add the test zip as a dependency for our results.txt, right? Because it is used to produce it. It kind of makes sense. So let me do that. But by doing that, you should, it's the same problem appears as before. Like we cannot refer to all the dependencies anymore. If I do this, that makes sense because this is actually a dependency for results.txt. But now I cannot refer to all my dependencies at this point anymore. So what can I do now? I know how to refer to the first dependency, which is good. I can use that in here. I can use this. But now, how can I refer to my DAT files? Yeah. One way around that is using some bash wildcards. I can do this to refer to all DAT files in my current directory, and that probably would work. That's one way to do it. I can probably show you another different way to do it later, but for now, let me show you how that will work. So if I do make clean, make now, you see that hopefully you get the same result. So which is good. Not in the same order. That is important. It doesn't necessarily come in the same order. And you see here, before it was coming first isles, then aves, then last. Now it's aves, isles, and then last. So there is no guarantee in which way the different dependencies will be processed. Something to have in mind. All of them will be processed if necessary, but the order is not guaranteed. Let me move on to my next one, and now so the same topic, trying to reduce repetition. Another useful utility of make is the use of pattern rules that allows you to match section patterns in strings. For example, I can use this symbol, percentage symbol, and this will match any file, any target that ends in a .dat extension. And I can use the match section of that pattern, whatever comes before the dot, within my rule. So I can use it like here. So this could match anything. It can match isles, it can match aves, can match last, and that will also be the same word that appears in here. Let me show you how that might work. So let me now save this. I just want to reuse the dat, recreate the dats, which is fine, but it sort of makes sense, and you might wonder, but you didn't remove the other two rules. What is that? It's not clear that this is not actually just using these two other rules. Okay, what if I do make Sierra.dat? Obviously, that target is not present in my makefile at the moment, right? So if I do that one, you see that it was processed. It did something for this one, despite the fact that this is not specifically there's not specifically a Sierra.dat rule for it, but still it matched the pattern that we provided in here. It does something that ends in .dat, and because that matches that pattern, it will execute this rule, which is useful. So now we can probably get rid of these two rules, because now they are contained in the first one that uses that pattern. And I save this. Now I can let me do a make clean. To make that. You see now that they are processed. That I can recreate my DAT files again, which is good. And also now my make file is a bit shorter, which is good. I have compressed 3 different rules into only one, which is better because it saves me editing time, also reduces the chances of making mistakes. Right. Any doubts up to this point? If not, let me move to the next bit. Maybe there is one question, I think. Actually, there is one bit that I'm missing. Probably I should show you the use of wildcards with make is in this way, as before. So there is another possible way to solve to use this rule. If you take a look at the implementation of make, it has so many different variables and functions and parameters you can use that most of the time there are alternative ways of solving something. That's a good question. I don't know. I suppose the one might be that whatever comes first. If both match, it might be the first one with processed. I'm not sure. Maybe by doing some testing, maybe you specify both with a different action and see which one is executed. That's not my answer to that question, but yeah, that's my thinking. Probably the order of the rules. Right. So I wanted to show you this this wildcard. So this is different from the one that you used before for and the results .txt rule. In here we were using a bash wildcard. This is a make wildcard, and what this does, this bit, this dollar symbol and star symbol, gets replaced by the by this whatever was matched by this my percentage symbol in here, which it's another way to do it. So it will, if it was abyss, for example, this will be replaced by abyss and then .dat, which is one way to do it. Let me just show you. Make clean, make that. You see, it's the same output. Make file. So it is, and for all purposes, I could have used this dollar symbol, at symbol, but just just if I used it this combination, I wouldn't have the chance to show you this. So for now, I will leave it like this, and hopefully it's not confusing. Could we use instead of in the rules? Well, no, in the action, you mean yes and no. For some reason, the percentage symbol is only used in the target and in the dependencies. And if you want to replace the stem or what it was matched by the percentage symbol on the action, you need to use the wildcard. So, as far as I know. Right. So far I have showed you some several automatic variables, so that can and some pattern substitution. Because Make is kind of a programming language as well. It supports the use of variables, which is very handy. Say that we want, for example, to further reduce the repetition in this script. It might be good to have a variable, for example, to refer to the different Python scripts. Do we need to keep the line that? No, we don't. We can probably, I think we can replace it by the phony target that we have. That's at this point. I think we just added it before because I was trying to exemplify the use of one of the automatic variables. But I think you can replace it by using right. No, at this point, no, you need to replace, you need to keep it, I think. No. But if I were to, for example, oh, oops. Sorry, with mistakes with the keyboard. I could do it like this probably, and then I will be using that target now. Make clean, make that seems to work. Okay. So now I'm reusing now that target. Right, variables, and trying to continue reducing the repetition in this file. We notice that we are using countwords.py in 2 locations. It might be useful to have a variable that specify what are the names of my Python scripts, so that I don't need to edit it in several places in my make file. I need to edit it in only one place. So, for example, if I do count source, short for source, and I do countwords.py. This is a variable assignment. Now this count underscore source or src has this value, countwords.py, and I can use it now in different places. So, for example, before I start using it, let me define some other variables. So, language, I can use Python because I can see I'm using Python in several places. It's also handy if I ever want to update my scripts to use another language. For example, if I update my scripts to use R, I only need to change the language in one section, in one location. And I can also, for example, define how these scripts are run. And this is also a demonstration of how to refer to those variables. So language, then count. So this will be replaced by whatever value was stored in language, so Python, and this will be replaced also by this value. And in turn, this will be, So Python count words will be stored in count x underscore x, which will be a third variable. So you can see here that this is the grammar to use to refer to a variable. This dollar symbol and using this square, these brackets, sorry, no square brackets. Right. Now we can with these variables we can update several places in our makefile to use those variables, which can be useful. So let me give you an example. So I will replace this one, but please go ahead and so now this bit will replace by whatever language I chose at the beginning. So if I save this and close and make clean, yes, the definition of the variable needs to come first. Make. And now you see that the last action where I used the variable language was replaced by the value I had stored before, Python, which is fine. So now we can, with some confidence that it actually works, we can use it in the rest of our makefile. So, for example, continue. We can keep using. We could use it here. Python count words. We can use Python. We can use language, and then we could use count source. But we already have another variable that we also define, so we can remove all of this and use count x, which kind of makes sense, right? So this bit will be replaced by whatever was saved in here, which in turn was a combination of these two variables. Which that makes sense. So that's one way to keep reducing the amount of repetition that we have in our script. Another thing useful to know is that you can use include file. You can refer to external files. So let me demonstrate that. So if I use head to a makefile, you see that the first 3 lines in my makefile correspond to those variables. So let me just print those lines with this head and then -n3. Yes, it is preserved, which is handy because we want the space between Python and the Python script. Yes. That's a good point, actually. Yes, thank you. So I want to redirect this output to a new file. I want to config.mk. Could be another name, but just for now, because it's going to be basically the configuration we're going to be using. It makes sense to call it config, and then something that resembles make. And if I do nano config make, you see that I have my 3 lines with my 3 variables. If I close this file and I open again my make files, I will remove now these lines because they are already saved in the other file. But what I can do is to use a line called include config.mk, and this will search for a file with that name within the current directory, and if found, it will include that. It will place the content of that file in the position where I have this include statement. So let me save this to a make link to make. You see that I have the same output, and everything seems to be working as before. So you can see that it's actually working. And so now make. We can continue adding more variables. So it might make sense to add some for the code that we use to do this test. Zip dot py. So this is the one that is used to test the hypothesis or the rule, and maybe want to specify how we execute that in that particular script. So use language, and then the name of my so now I have two new variables that I can start using in my make file. So let me save this and manual make, and I can use it in here. And cpf dot sorry, I can use it in here. I forgot to replace this one before. Count and I can there are a couple of ways to do this. So I could leave it like this. So using the language variable and then referring to the first dependency, or I could use cpf excel. So you see now that there are different ways you can arrange your script that gives you a bit of flexibility when developing more complex make files. And I know it's starting to look more complex and also more compact, and it's good. So one advantage of having the configuration in a different file is that you don't need to, open every time your make file with probably all the different rules just to modify some, for example, to modify the name of the script you're running. You can just use it. You can just open the configuration file, which seems a bit simpler, and update that file, and hopefully it gets everything in your make file should be updated properly because you're already using the variables defined in the configuration file. So let us test if this is still working properly. Just make. So yeah, seems to we keep the functionality still, so it works. So right, so far we have seen how to define variables, how to refer to them, and how you can include external files into your make file. So let me move on now to something about functions, because make also include support for functions. Let me open again my make file. So please let me know if I'm going too fast or not. If nobody stops me, I just tend to just accelerate a bit. So okay. So again, what the subset of the different variables and functionality and functions that we are giving you during this course is just a subset of all that is available. So for a full view, whatever everything is available, you can take a look at the documentation of Make. For now, just give you some of those that can be more useful. Yes, it is possible. Actually, side by side, I just didn't want to. I can use with, for example, with Beam, but I didn't want to add more complexity. I didn't know if, but yeah, that's a good suggestion. Thank you. Having both files open side by side. Right. So one of the first functions I want to show you, it's the use wildcard. One that is called wildcard. So say that I want to define one of my another variable. For now, I will just put it in here. For now, I can add it later to my configuration file. But, so the way it works, this function is I need to use a name wildcard. I will do books. So what this will do is it will execute this. It will treat this as a bash command basically, and it will match all the different text files that are within books, and it will the list of those files will be saved in my text files variable, and so and I can, just for the sake of saying what happened, how this works, I can create a phony target called, for example, variables. So this and this target will run this command. And I'll show you in a moment what this means. I have also introducing a new command here. So let me just. So what we know so far is that a phonic target will be executed every time I specify it. And so variables, if I do make variables, it will be run, and it will run any action that I specify for that target. In this case, this one. I explain in a moment what is @echo means, but for now, bear with me. I'm just using some text in here, and then the value of whatever was stored in this variable that I assign in here in this line. So let me save this for now, and I will call that target by name. So you can see here that this is printed. So text files, and then a list of files. Books addis.txt, books isos.txt, so up to Sierra, which is kind of what I was expecting, because that's what I have on those are the txt files that I have in that directory. Now let me explain what was that echo, that @echo make file. So this @ symbol, when it is the first symbol in the actions, in an action, tells make to not print that action. By default, what makes does is it will print whatever action is being executed. So let me remove that @ symbol and save this. and do make variables again. You see here the difference is that now make is printing this command. So this is the command that is being called by the rule, and then this is the output of that command. So those are the different things. One is the actual command, and the other is the output. So by adding that symbol, I'm telling make do not print what is the command being run. Just print whatever output is produced. Hopefully that's clear. So make variable. Could be. Let me think. Perhaps. No, don't think so. Because we'll still call the no, that dash n will only be the try run, so we'll still have the same functionality. If we just want to update files, but in this case, this target is not actually updating any files. So, right. Okay. So this is the first exemplification using this function wildcard. Allows you to have access to some matching patterns within a directory, for example. Now, let me continue trying to show you other functions by trying to process what we got stored in this variable. So let me now call that files, and as we saw, text files now holds a list of all the files, but it starts with the books and then / and then the name and that. We ideally just want the name of the file without the books / starting pattern. So we can get rid of that with a pattern substitution function, and we can make has one that is called add subst, which is short for pattern substitution. And this function takes 3 arguments. One is the pattern that we want to match. Then a replacement string, so what we want to replace it with, and then a list of names of where we want to do the replacing. So let me try to simplify that. Show how it works, for example. So I want to match this, and I want to replace it with this kind of pattern, and the list of the strings where I want to do that process is this list. So it will look for strings with this pattern, and it will match anything that comes in this position, and it will use that anything in here as well, and it will add a .dat. So, and it will do it in this list of files that we already saw what is being stored on this variable. And let me see what is doing. So I can add here echo that files and that files, and if I do make variables, you can see here, and my text files are all of this. And now after the pattern substitution, that files has this content. So the pattern only took the abyss section, for example, the abyss bit, and added a .dat to it, and it did it for every single item in the list. that was stored in text files. Hopefully that's more or less clear. Right. Now we can keep using now that we have this variable, that file that has this this content, we can use it actually. So now if you realize, now we are automatically detecting what are the text files that we have in our directory. We don't need to specify it anymore in our makefile. So if I do nano makefile, I can for example use it in here to remove the .dat files. At the moment it's removing every single .dat file that was there, not just those that were produced by our makefile, but every one. So, which is okay, there is no other process creating .dat files, but might not always be the case. We can be more selective by using the variable here, .dat files, and if we only remove those that were detected or that will correspond to a file in our books directory, which it's a bit better, I think. I can also use it in here because I was specifying by hand my .dat file manually, so I was hard coding those files. So now I can do .dat files like that, which is also I think a bit better. If I do so this, you can see here that now I'm removing those specific files, and now if I do make, it's actually I should yeah, sorry. Sorry, just opening this bit with those. When I type make, it runs just the variables target because that's the one I left at the beginning. It was taken as the default one. That's not the one I want as the default. So I need to move this target somewhere down below the results. So I will do that with the help of Beam because it's a bit simpler. I will move it at the end actually. Hopefully it's clear. There you go. And we make clean. And then make again. You see now that every single file in my books directory is being processed. So including Sierra. It wasn't before. Without me actually needing to specify directly Sierra, which is I think a step in the right direction. And now we can see the content. Now, so hopefully you can see now what would be the advantage of this. For example, if we wanted to go ahead and, so we only have 4 books. That might not be enough to test the rule that we started with, SIP's rule. Might be useful to have more books, tens or hundreds of them. So in the training material, there is a link to the project at Gutenberg where you can download several books that are in the public domain and plain text format, and you can place them in your books directory, and now your makefile can detect automatically files and process them and recreate your results.txt with the statistics for those files, which I think is quite neat because it saves you a lot of time now, and you can see now that Make can help you scale things up quite well. Um, so that we leave that as an exercise for you to try in your own time. I would like to add a bit more to my makefile at the moment. So as any script, I think I also mentioned this before, adding comments to your script might be useful. So one way to do that is by adding, for example, we know that hash lines starting with a hash symbol are treated as a comment. We can use that, for example, to mark some lines that we want to include as some kind of documentation. I will use two hash symbols, which could be hash and another symbol, or hash, three hash symbols, could be something else. But for simplicity, I will just use two hash symbols. But it needs to start with a hash, obviously, because I don't want it to be treated as a command by make. We will see in a moment how this works. So .txt, and this will generate zip summary table. And I can do the same for any other command that I want, to add some kind of explanation. Any other target that I want to add an explanation for. Words in text files. Clean. What clean does? So clean. Remove auto generated files. And this one. Good. Variables. Print which variables I'm using. Right. So, and I can use another phony target. Phony called help. I will be help. So this target will have a dependency on the actual makefile, and it will run this command. So it won't print the command; it will just print the output of the command. So set-n. So for those of you who are not familiar, set is a Linux command. It's very common on Linux distribution, probably also on Mac. Which what it does is a pattern substitution. It searches through text files and find lines matching some pattern and do something with them. And you specify what to do with those lines and what patterns to match through sets, cells, specific rules and commands. So for now, you can believe me that this will search for lines starting with two hash symbols, and then we'll do something with them. In this case, I'm not doing anything, so this is empty, and then I'm telling it to print those lines, and I want to use the first dependency for this target, in this case the makefile. So hopefully that will work. So let me do a make, and I want to, because it's a funny target, I will call it by name, so make help. And you see my set command is calling is processing my makefile and searching for the strings that start with a double hash symbol and printing the content. So this is a way to tell whoever is using this makefile what are the available targets and give them an idea of what they do. Why to use a dependency as a dependency? Because it allowed me to use the symbol as to refer to it. I could have run it without a dependency, I think, and just specify here make file instead, and I think that will probably have worked as well. But just as trying to exemplify some of the use of the automatic variables. And I think that I missed one. Yes, this one printed clean because I use only one hash symbol. Now there it is. There you go. Probably need to move it a bit, one space, but yes, that's one way to add some information. It can be useful. Kind of people using the makefile might be expecting to be able to use pass a help target and to print something meaningful. So this is one way to do it, either for sharing with colleagues or for your own self. It is a good practice. So I think we are ready to start with the conclusion. So right, there are a couple of very good examples and exercises in the conclusion section, which probably I don't think I would have time to go through them, but it basically they use everything that we have covered during this course to allow you to add the functionality, because you remember we said there is one Python script we haven't used, which is the plot counts.py that produces figures. So one of the final exercises is adding functionality to create those plots. And basically it is adding rules and dependencies to create the plots, and it's very similar to what we have done, and there are some solutions in here as well. So take a look and give it a try, and then you will have your makefile that can detect any text, any new text file that you add to your books directory, create a summary of every single one of them, and also create some very nice figures for you to add to your papers. So hopefully you can see how it could be useful in a production environment or doing your research. And also there's another exercise that allows you to develop another rule to kind of archive everything that you produced. So your scripts, your input files, your output files, and create a kind of a zip file or tar file in this case that you can share with colleagues. For example, if you want to share every single bit of everything that is necessary to run your this particular workflow, you can put it together in a single step and with a single rule. So please give it a try, and if you have any questions, you can probably answer them later on. So for now, Jenna, if you have anything you might want to ask, or anything that wasn't clear, anything you think might be worth expanding on, was it too fast perhaps or not? Would you like to start going trying to point you in the right direction for the first exercise and for the last section? I think we still have 10 minutes. The function of wildcard, yes. Yeah, it's not very straightforward. That one, I think, it's probably through the use of the actual function, and through try and error a bit. But yeah, so yeah, make has so many different functions that can be useful. So right. I don't know, Juan. What would you think we should try to go through the last exercise? I'm not sure we can finish it. Still have 10 minutes, so we were trying to. You're happy
Yeah,
with
what do
me?
you prefer to do the
Yeah,
exercises of? Yeah, we have 10 minutes. We can either do the
yeah, happy.
exercises or go for lunch. It's up to
Yeah, you
the
don't mind me
attendance. So
stopping halfway through the exercise if we for some reason don't manage to finish it. I can start, taking you through the right direction.
yeah, that's
Uh,
fine.
yeah, it's good. So right. So as I mentioned, the last exercise, what it's asking you is trying to make you add functionality to create the figures. So, so let me open my file, make file. So just quite long now. Uh, so we want to add some new rules and update some of the ones that we already have here, and add some variables to create some PNG files from our DAT files using plot counts.py, and remove all two generated files. Right. So we can start adding the rules probably. So let me add it somewhere around here. Could be anywhere except at the top. So we'll call this figures, or I don't know, plot figures from that file, and I will call it figures, and I should have some dependencies, so they need to be the that files itself themselves, but also need to I also need to use plot counts.py. However, at this point, I realized that this might be better to add it in the configuration file. So let me save at this point and go to my configuration file. Nano and config. Let me add here a couple of variables. So say plot source and plot counts.py, and then plot exe, just to have the same notation that we've been using. So language, and then plot, yeah. So I have those two variables now. Probably use. So save this and return to my make file. Now I can, instead of using this, I can probably use plot scene, and I can use now the command that I want to. It was I can use the file, and I can I remember correctly, was I need to use the name of the file. Um, and add PNG here. Compound. Sorry about that. Trying to think now how to add, because I need to provide only one file. Sorry, just messing this here. Oh, sorry. Probably this one we do it. Oh, sorry. It's a good idea, yes. Pardon me. This on the fly. So you mean something like this? That will probably depend on something like that would. You know what might be better to first process all the identify what are the files that we need, as we did with the files. That way we will be sure of what we need to process. So let me do something like this here first. PNG files, and I can probably do this same back substitution. Now, yes, I can do something like that here. And so I can, let me for now comment out this bit because I'm still working on that rule. But I want to see how this is being, how am I, if I'm identifying the right variables, right? And so let me add in here to see if I'm in the right direction. And PNG files. Let me save this and make variables. And yeah, it seems to be correct. This is the files that I want to create. So let me continue going into that direction, and it might be good to add. So now might be good some figures on target. It would depend on those files. So that when I call this target, it will try to execute rules for this, for whatever was included in this variable. Now I need a rule for something matching.png, and that probably would depend on file with the same name, that file with the same name, and probably my plot source, and then plot exa, and we'll use the first dependency I have in here, and then save it with the name of the target. Right, we can probably now test this. Let's see. So let me do a make clean. It's an operator, line 20. Forgot to add what is the name. There you go. Make figures. And hopefully now I should have something here. And I have several PNG files. Seems to work. And if I check my directory and try to open those files, seems to have the right files. Yep, I think that I cannot show you easily. Seems to have been created, which is good. But now I still need to add one final bit. That is, I want to remove everything when I clean this when I do the make clean. So PNG files. So that should do the trick. So let me make clean. Oh yeah. No, probably use spaces instead of. Yeah, I use spaces. There you go. Oh. There you go. Now it removes also my make file, my PNG files. Good. So right. So I think I have added the requested functionality. Unless I missed something. There's a question in the chat saying what was the purpose of the figures PNG files, especially if the PNG files have already been defined earlier in the make file. Let me see. So I use it in here. Here's where I define what are the PNG files that I want to create. And later on, I use that variable on this target. And so this target will whenever I call this target, it will search for these dependencies, which are the PNG files. And if they need to be updated or created, they will do so by searching for a rule matching the pattern, this pattern, because they end in PNG. at least as logic. Um, so yeah, I think we are already beyond the time that we um, scheduled for this course. So I don't know. Hopefully, I think that was what was requested for this exercise. So and hopefully, so it was clear. If you realize we kind of did something very similar to what we did with the DAT files and how to process them. Um, so you can give it a try and see if you can follow the logic. Again, in the material training material, you have solutions that you can compare your solution to the one provided in the training material. Um, so right. So I think probably might it's a good point to finish.
Yes. So
Yep.
yes, thanks for today's lesson. Was quite good, and yes, I think it's now lunch time. So have a nice rest of the day, and see you tomorrow. Bye.